Yeah, for those that have dropped off, probably a dumb idea. They probably should have stayed this week to at least see what was coming up for their repeat year. For those that are still here, for the good student, it's going to be a really good challenge. You're going to learn a lot. For the students that are on that borderline of the cusp of not passing, you're going to have to step it up because there's going to be quite a bit to learn this week. We'll start with my lecture, which won't be too bad. But the worst part about the lecture is I'm going to show you assignment 3 and 4. That's when it's all going to start becoming a bit of a concern. And then we will go to the lab, where I'm going to stun you with how to work out reinforcing spacings and reinforcing bars in concrete. And how we work it out and how we draw it. So there's quite a big lab session. Please don't think, well, you know what, I could miss this lab tonight because I've got such a good assignment 1 result. The other bad news is that you will not get your results back as quickly for assignment 2 because I know that you think that you did the assignment and there's only you in the whole world, but there's actually 100 students that I'm marking at the moment. And I really busted my gut to get those results back. And the other bad news is for those of you that think that you didn't have to do anything to your existing site plan before you went, after you went save as, you did, but not for marks for the existing site plan. The idea was you took the existing site plan and went save as and created your proposed site plan to start with, right? And a lot of students said, do we have to fix up anything on the existing site plan? And my answer was, no, you don't, because I'm not remarking the existing site plan. But if you bring those problems into your proposed site plan, yes, then you've got problems, okay? That is why I spent hours and hours doing over 100 lines of feedback to you on assignment 1 so that you would fix some of those things up, right? I didn't do it just because, hey, I don't have a life. Well, that's probably right at this time of the year. So, yeah, you should have fixed those up. You should take note of those, and they will roll on into the next part of your course. I'm just trying to remember my new password that I changed this morning. That's right. Let's start with text. That's going to change, isn't it? It's no longer a metre drawing, isn't it? Okay. The text will still be 3.5 and 5 millimetres, for those that are wondering. I think I've written it somewhere anyway. But the scale will change to 1 to 20 for your drawings. The text is still going to be 3.5 millimetres in layout. Can anyone tell me what it's going to be in model? 1.75. No.
It's 0.35.
0.1?
35.
Would you say?
0.07.
0.07? No.
0.0035.
There's actually half a mark coming up here, if someone could do it. Before the lecture's over, of course, would be nice.
0.17.
Well done, mate. You've got yourself half a mark.
1.7.
It's millimetre drawings from now on. Okay? So to do that, we went 3.5 times 20, which equals... Did you say 7?
7.
10. Sorry, I have to take that away from you. Which equals 70. Alright? Which is what it is. That's how simple it is with millimetre drawings. Yeah.
Is it for both of the assignment? Oh, just.
Even?
Is it for assignment 3 just or for?
Yeah, so for assignment 3, it's millimetres. So cast your mind back to either me or Ingrid. And with millimetre drawings, everything's drawn in millimetres. So when its layout space is asked for 33.5 3.5 millimetres, and the scale is 20, that's what you draw it as. Okay? And please note, emails, texts, whatever, throughout the next 4 weeks. What is the size of the text? Because I missed lecture 8, okay, there it is there, it was very simple, and you will have to do headings this time, so there will be some 5mm text, and you'll see that coming up shortly. Assignment 2, a lot of students seem to think that by doing just the butterfly wing like this, and they went, hey bro, what are we offset by? And someone said, oh, it's 0.2, okay, cool. And then what about this side? Oh, that's 0.4, okay, thanks. And they joined up and they found the butterfly wing, and they draw that in there, and they thought, oh, that's going to be a pretty easy 7 marks from Roger. No, it's going to be a very easy 1 mark from Roger. Did you label the wings toe of fill, top of cut? Did you put the batter symbols in the correct place?
If you use batter symbols, do you still need to label it with words?
No, that's fine. Did you label the cut area and the fill area? Did you put the flags in for the A and B sections? Did you not put the flags through the platform, like Ingrid showed you not to do through anything? Did you put the line of equal cut and fill and label it and put it in a line type that was different to all your other ones? Did you take your survey pegs off and your survey data off the proposed plan? And did you put a line on the proposed plan that was a lot thicker than the normal lines? That is how you maximise your mark in my class, okay? So with taking that forward into assignment 3, the more students that ask questions, the more they get answers, the more they get feedback that ends up in real marks, okay? With assignment 3, there's quite a few bonuses to be had, and sorry about taking that bonus away, it's just that you and I both are no good at maths, so, you know, never mind. I swore you said 70 there. There's going to be a bonus for drawing extra stuff on your 3D. There's going to be a bonus for one of the bars that you have to calculate, and it's not going to be the easy one. And if it's a bonus bar, that means that the past student nor myself will be able to give you a hand in calculating the numbers required for it. What else? The assignment's fairly well split. There's like 3 weeks and I think 2 or 3 weeks for the second one. And on the face of it, looks like I'm being quite fair because in the middle there's the semester break. So you can add another 2 weeks to some of those calculations. So it looks like a lot of time to do not very much work. But I can tell you that when it comes to this one, don't leave it till Sunday to do it because do you know that game Tetris where the things come down and you're going to move them into the right place all the time, right? It's like a puzzle happening. It's the same thing going to be with drawing up your plan for reinforcing. There are rules and there are things that you can't do, and if you haven't got it nicely drawn up by about Saturday, you will need time to move things around on AutoCAD. And if you don't have that time and you're panicking, you're going to make send in some pretty substandard drawing and wonder why instead of 5 you end up getting 3 or something like that. Okay? So save some time to do that, to play the game, to get it right. And calculation wise, I guess, yeah, there's a chance to kind of do the hey bro thing again because it's all the same assignment. But if you can try and at least do some of it yourself before you start comparing, it will mean that you'll do well on the test because was there's a lot of the testers doing reinforcing calculations as well. And to be fair, the test is a little bit easier than the actual assignment. So if you can get the grips of the assignment, you'll do well in the test. This time around, there's going to be 3 questions from concrete, 3 from steel, and 3 from timber. So I divide it up, right? And that's 9. And then there'll be 11 questions that I will go over in revision. All right? So for those that did quite well in the last test because their calculations were good, there's an opportunity there to do quite well in the second test as well. So what am I going on about? Let's see. Today we've got to get through some notes, and I need to show you the assignment, and in the lab class we will go over an example step by step by step, and I'll take you through it. My model answers are kind of just answers. In the lab class I'll splatter the whiteboard with all sorts of ways, you know, the calculations involved, and you can come and take a photo of it afterwards. So you'll have quite a good set of notes on how to figure that out. There's also going to be an example made available to you that is a class example that you can also have a go at home in your own time, but it's got a very detailed explanation of how to do each step by step, and it pretty much covers most of reinforcing. So that is one that's quite a good one to refer to while you're doing your assignment as well. Next week we'll go on to do steel, and the following week we'll go on to do timber. And that will be kind of the end of your formal lectures and everything like that. I think we'll have a revision lecture, then a break from lectures, and then the test. I will, however, in about week 10 or 11, not quite sure when, I'll give you a special little demonstration on how to do 3D, and I'll do the assignment. I'll take it to a certain point, but that's when the monkey see, monkey do stuff finishes. You're going to have to start getting in there and using it and, you know, manipulating it. Some of you will find it really cool because it's a little bit like playing a 3D PlayStation, Xbox or something, because it's kind of cool, but it does drain time, and you don't have time because you've got exams to study for at that point. So I set out I make it very easy for students to get 60% and quite hard to get 100%, but there are things you can do to actually get a bonus on that as well. And I'm giving away one whole bonus mark for that if you want to go a bit further. In the past I had a Russian student once that put a mint jet inside a shed that I designed, which was kind of weird. And I had another student who decided to have a monkey hanging off the edge. It was a 3D monkey, which was pretty cool. The edge of a bridge. It was about 3 years ago. I laughed at both of those before I took marks off. It's an engineering project, okay? I did get a fright when I opened up the doors of the shed in 3D and there was a blooming jet plane in there, but the student did well anyway. But yeah, it'll be a chance to have a little bit more enjoyment out of the subject. Right. Remember that at the end of this, I'm hoping you can go to employment and kind of, I liken it to coming down in the Second World War with a parachute on, and the Germans are all shooting, and you arrive and you've got no skills at all, so you just sit there and wait to be shot, compared with you guys arriving in the workforce and landing on the ground, taking off the parachute, running and shooting at the same time, because I'm giving you the skills to arrive in an office and be kind of ready. I'm not saying you won't get shot, but I'm saying you'll have an opportunity to, you know. That's right. I must remember that, thank you. When you're here next year, I'll repeat that joke. there any questions on what I've just said? Oops. So there's a couple of sketches that I'll do on the board today as well. Make sure you take a photograph of those because they are in the test. I'm not quite sure why this isn't logging in, but we'll give it another go. Right, there. So those that have got their laptops with them here, I'll make this available in a second. Oh yeah, so your week now is going to be split a bit. It's going to be engineers only and surveyors only. So I know that you guys can be rather nosy, just like I can be, and you're going to poke around in the surveyors one and go, oh, wonder what the surveyors are up to. That's fine, I don't care, and they probably don't care either, but what is not fine is to put your drop in the wrong Dropbox, okay? So please, you're being warned, because what happens is, I download the Dropboxes all at once and I do all the marking. And if your name's not there, you get 0, and we carry on from there, and then about 4 weeks later, I get an email from the student that did it, because it's normally not the brightest star in the sky. And, oh, please help, I've got no marks for my assignment, blah, blah, blah. An hour of my time is wasted, and eventually I get round to sorting it all out. And then they expect that to be uploaded onto Moodle with the uploaded mark results as well, which is more work for me. So anything that I have to do that's more work results in, yes, and I'm looking straight at the cameras, less marks for you, okay? So don't do that. If I made you do more work over and above other students, you would expect more marks, obviously. That's how it works. So, yeah, you'll see that quite clearly at the top, surveys only. Now, you guys and girls are going to have to do a brand new drawing for assignment 3 and 4, right? So you're going to have to start from brand new. Oh, thank you for doing that. I wonder how long the others were going to sit there waiting for something to happen. It's okay, just, you know. Comedians have a plant that they put in the audience, you know. I've got mine up the back there. You've also got a new name there. Okay, so you're in this section here with the survey, with the engineers, sorry, and you will be required, when that eventually comes on, should be as soon as, you're going to be required to do a brand new drawing. So you'll have to go File, New, ACAD, just like you did last semester. And look at this, I'm being nice. The biggest problem that some students had, and a lot of them aren't here anymore now, is they didn't go File, Plot, and then selected their printer. When I teach my class, I always say, what do you do when you normally plot a Word document from your computer? You go from your laptop at home. File, Plot, and there it is. You choose the printer to print it to, which is your mum's such and such, IBM such and such. You click on that and you go print, right? That's you printing a Word document from home. It's automatic normally after that if you connected it. At Unitech here, you go File, Print. The first thing you do is you pick the printer. The second thing you do is you pick the paper size. And the third thing you do is you check the units. It's got to be equal to 1. If it's not 1, then unit-wise, you've stuffed up your whole drawing. Make that 1. And then the fourth thing you do is exactly what you do on your wedding night, which is you fake it, okay? Which I tell my students, so some of them weren't laughing, but others are like, what? Okay. In other words, you go down the bottom, you go save, and then you get out of the drawing, which means it automatically is the right print size. Now you bring in your title, now you adjust your viewport. Now you bring in your title block. What students did in assignment 1 and 2 is the exact opposite. They opened up my drawing, they went into model space, they stretched the viewport, they put the title block in, and they went, oh, it doesn't work. So they emailed me, it doesn't work, make it work. I said, please refer to my demonstration and your notes from technical literacy. It's not fair. Why? I don't have my notes from technical literacy. Well, you do need them to complete this course. So at that point you do your title block. If you need to scale it up, you do so. If you need to stretch your viewport, you do so. And then you zoom in and do your scale. Okay? You need to do that with assignment 3 and 4 all by yourself, starting from scratch. The good news is we do have labs, and I am happy to help for assignment 3 and 4 on students doing that if they've got a problem. I think most that are still here won't have any issues, but if you do, please ask. The other thing is, title block on a layer called title block, viewport on a layer called viewport, no lines over the edge of the title block. I know some of you are very proud of your very, very long names. My name is Gibb, G-I-B-B, this big, and it fits perfectly on the title block. So I penalise anybody that does have a long name, because I've been jealous all my life. You don't take your name along over the edge and so on. If you've got a big name, just put your initials there. I don't care, it's fine, okay? You'll find in the workforce you're going to have to do that anyway. They won't accept big long names going off the side of drawings, okay? So that's one thing. The other thing is the scale. On the long section, the scale should have been 2 scales in the bottom, 1 to 50, V, 1 to 100, H. Probably the other way around actually, but it doesn't matter as long as they're both there. On the plan, 1 to 100. On the sections, 1 to 50. The LT scale is something that you are setting your scale to. It isn't something you have to tell the whole world about, okay? It doesn't have to be everywhere on the drawing, and it definitely doesn't go on the title block. The other thing is, it is we are doing ENGG 5202, civil and structural drawing. Somewhere along the line you need to put something like that onto the title block. I'm happy if you just do civil and structural drawing, but you know, you should really be putting the full details. And you should put what the drawing is, which is a plant and maintenance shed, building, can't remember, building I think. And then put section AA or section BB or long section or whatever is relevant as well. So that all needs to be on the title block. We are starting new drawings, so it'll be sheet 1 of 5. It's going to be a, I'm pretty sure it's 5. So sheet 1 of 5, sheet 2 of 5, sheet 3 of 5, sheet 4 of 5, sheet 5 of 5. All right. Last semester, I allocated a mark to getting that title block right, and another mark in the long section. And if you have a look at the mark distribution, I don't think there was many more than about 3 students got 1 mark for each of that. So please, I want that perfect in the second semester. So we have a set of concrete notes which will lead into helping you with your drawing. As we go through them, there is a lot of notes that will be perfect for putting on in your notes section. And at the same time, I will stop and say there's something on that in the test. So you need to kind of either go back and revise your lovely videos or write down what I've just said, okay? Those that did the test, we all did the test, you will notice that there were questions there. That is exactly what I said as we were going through the lectures. I'll be doing that again all the way through. It won't be all of them, it'll be most of them. And I know students come up to me afterwards and said they got 2 out of 3 of the example ones, which was quite funny. Never mind. so we'll go through the notes, we'll do that. At the end, I'll explain a very, very basic reinforcing drawing. But prior to that, I'd like to introduce right now the week 8 notes, the assignment. So those, that should be available. Can you see it at the moment if you've got your laptop?
Yep.
All good?
Yep.
Can you see it? Okay. I'll just save it and open them. For the downloads, we should have. No? Okay, over here. No, here we go. All right. So, yeah, that's what we're going to be doing for the next 6 or 7 weeks. As you can see, it's a truss roof.
This screen is frozen.
Frozen.
Yeah.
Yep.
Certainly doesn't like the cold, does it? Okay, we'll go to laptop. And then go back to PC. Has it come up? Have we had anything yet?
Not the assignment, but not notes.
Not yet.
Not, don't have anything yet.
No, has anything appeared behind me at all?
No.
Just screen.
And it's been like that the whole time through?
Yeah.
Yeah.
What happened to my plant? Did he not tell me?
He was sleeping.
He was sleeping, was he? Okay. This is going to be an issue. We'll see what we can play with. No, that's the lights. Curtain. That's working. That's good. That's gone to the laptop, which is taking that off there.
There should be something.
The what?
At the roulette at the bottom on the left.
The what?
Oh, that's just the lights.
I
Oh,
don't
the
think
lights.
so.
That's the air conditioning, that's definitely on. Turn that off, I think.
Yeah.
Nothing else? Okay, well, I don't particularly want to have to go over all of this, just,
That's complete.
Big Bun? Yeah. The PC connection may, oh, what's that doing there? Ah. Thank the lecturer before me for that. Let's take that out. Okay, what if I was to do this? Is that coming through at all onto?
Oh, yeah.
Yeah.
Alpha Mark.
To me?
Yeah.
Yeah, the problem I've got is that's off my screen, and I can't see it on here now.
Oh.
So, I know. Display settings to detect. Extend these. Right, I can now. So that's what you guys are seeing?
Everything's going.
Okay. It's going to be an interesting session, I've got an idea. Luckily, I'm an engineer and know how to think laterally on things rather than, no, it didn't work, try again. Is that coming onto the screen?
No.
No, yeah.
It's not lucky. Show on only two, extend these displays, duplicate these displays, keep changes. Is that it?
Yeah.
Yeah.
Always do.
It's crying a little bit. Big pardon?
Something's blocking the PDF.
It's, yeah, it's, I don't know, what's that? Let's put that down, let's go to there, no. Okay. Yeah. All right, we'll do it bit by bit. You've had a bit of, you did see a bit of a 3D up there a few minutes ago? I'm not sure.
No.
I'll go over the assignment first and we'll see what we can show you. So the assignment overview is you're going to be doing a plant and equipment building. You're going to be given a typical section, a part completed section, a 3D sketch, an example of quantities, and you're going to be given an AutoCAD drawing with some angles, beams and columns in them, which will all make sense a bit further down the line. Your task is using A1 ISO full bleed in tab 1 to produce a foundation slab reinforcing. So you're not having to initially draw the whole of the building up. All you'll be required to do is a drawing of the foundation slab. Now the foundation slab has got an elevation looks like that. So in plan view, it's going to look like that. So looking down on it, you're going to see those two corners with a dashed line. Okay? Basic technical literacy, you would have learned that. I don't want to see this, I just want to see that. And I'm not going to give you 5 marks just by drawing a box with some dashed lines. So obviously you're going to have to put reinforcing in there and call it up. The bad news is you'll be doing a reinforcing schedule, which is telling me exactly how long each bar is, how it's bent, what the dimensions, what the weight is. And if you get the schedule wrong, you'll get your numbers wrong on here. So you're duplicating your problems. If you get the schedule right, you'll get this part right too. So it's one or the other. So this is one part of the assignment, the slab, and it's kind of all you really need to draw in terms of lines and drawings. The next part is, the next two parts is your bar schedule or reinforcing schedule and your layout tab. Two will have a table of concrete quantities, materials, and that sort of thing as well, which isn't too bad, but that's another 5 marks as well. In assignment 4, which is the second hand in, you can be beavering away drawing this at the same time. Students often ask me, do you want to see this elevation view when I'm drawing my slab? And the answer is no. Take it right out of the viewport. Do you want me to draw it? And I say to students, it's a very good idea to draw it because you're going to have to do it for assignment 4 anyway. So if you draw it down here away from the slab, you won't see it in the viewport, so I'll be happy. And you can start drawing your building up for assignment 4, and then when assignment 4 comes, you've already started drawing some of the drawing up. So you'll have the reinforcing bars and elevation or view. I'll be wondering exactly what I'm talking about. I am wondering myself, so I'll show you.
So they're both related to each other, assignment 3 and 4?
They are related, yes. That's exactly the way that I would say myself. So I learned yesterday that if you click on that, you can maximise it, and I'm not sure how good that's come through, but I'll zoom in a little bit more so you can see a bit more. It is, the quality is not too bad, you can read it, it's just a little bit hard on the big screen. Let me explain it. You have a floor slab, much like I've drawn that one there. You've got a bit like your assignment in technical literacy, you've got some drainage here, and you've got a drain, an overflow drain, and you've got some reinforcing bars in here. On that, we then have some plates, then we have a column, more plates, a beam, and then on top of that beam we place our trusses. The trusses are timber trusses, and there's 7 of them going basically into the wall. In order to work out how you're going to represent these bars in plan view, it's not a bad idea to draw up this first. A lot of students do that. Last semester you did some reinforcing for Ingrid, and she told you and me that there is a minimum radius for bending a bar of reinforcing. And that minimum radius was, anyone remember what the formula was? You're close, but that's just a number. What if my reinforcing bar was 1 kilometre long? Would it still be 45? It's a formula for it. And the formula for finding the centre point of any bar is 2.5 times the diameter of that bar. So that radius there is equal to 2.5 times the diameter of this bar here. So in technical literacy we used a 16mm bar multiplied by 2.5 equals 40 millimetres to the centre of the bar. And remember, we did a P-line and then we filleted it with a fillet of 40 mils. Similar things apply here. I expect you to draw that up with the right line thickness. The donuts will be the right size as well. Some of these bars are different sizes. Talk about that later. So if you draw this up first, I don't want to see it for assignment 3, but you can use it because for assignment 4 you're basically drawing that up. So at least you would have done the bottom part anyway. Okay? Back to assignment 4. You're expected to draw up the 2 elevational views. That was one of them that you just saw. The other one looks very much like this. Except I haven't given you anything there. You're going to have to draw that up yourself without my help. Whereas the other one, I've kind of given you a little bit of help. Now I don't want to see a dash line here, but for those that have noticed, AutoCAD's got a command called mirror, so you could probably get away with just drawing half it up anyway and going to the other side. In fact, you could do half the slab down the bottom as well, if you wanted, if you were clever enough. You don't have to draw the tractor, okay? The tractor is not part of it, that's just me being smart. You do not have to draw a tractor. And if you come from a farm somewhere on New Zealand, you are not going to get any extra marks for finding a 3D tractor and putting it inside the shed. Yep.
Do you trace that or just make it up out of your head? I'm not going to do it. I'm not going to do it. I just want to know.
About 4 years ago, I found that online and I downloaded it. You don't need to know this, but it's made up of about 1 million different little dots, which is very bad drawing. But it worked nicely for my for the assignment, so I threw it in. All right. I've also got a Russian jet that I'm selling. If you want that online, it's stupid and a monkey as well. I have actually got that. I'll bring them one. You don't have to show the equipment here either, guys. It's just me trying to pad out the assignment, make it look like I do some work at home. But the good thing about doing it this way around is it does show you the sideways view and the front view, right? So it shows you, gives you an idea that we are looking that way and looking that way. So when it comes to the assignment and the 3D aspect, I think that's the 3D. No, that's the reinforcing schedule. Try that one. Yep. You'll see how things fit together. And you can see how these members go, one on the front and one on the back, etc., all the way along. Now, in 3D, what I'll do for you in week 10 is we'll draw up the slab. And I'll allow you to film it while I'm doing it. We'll do the plate. We'll do the column, we'll do the beam, I'll flip it round and put it on top. And I'll show you a couple of tricks because I don't like doing things more than I have to, so I'll do one of these and I'll just go copy, 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 and I'll do one beam and I'll flick it on the other side. And then at that point, I may, if we've got time, show you the way I would draw the truss up. It looks complicated, but you've got to draw that anyway for assignment 4, the view of it. And what you do is you go around it in the P line, and you extrude the P line. Now if it's behind, you extrude it that way. If it's in front, you extrude it that way. And then you basically stand it up, put it on top, and copy it 7 times. The purlins are the same. You're going to have to draw that little bit of the end of the purlin. You'll know how much to extrude it, the length, and you just extrude it once and go copy, 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 copy into the correct position. So when you stand it up, the purlin will be stood up at the same time. So it's pretty cool. I'll show you all that. And because I've shown you all that, I'll give you 3 marks out of 5 for drawing it. The other 2 marks, you'll get a choice. The type of things that I'll be asking you to do is draw the welds in, draw the bolts in, draw the angles in, draw the holes or the bolts and the angles. This framing is part of the extra bit. And then if you want to go a bit further, also external sheathing, roofing, if you're really after an extra bonus 1 mark, you're going to have to get your civil contours and put them onto the drawing and show me the civil design around it. You know, the bank and the batter slopes and all that sort of thing. So, in 3D. Yeah. Now, I'm very aware that you're going to end up having a materials test at some stage for a lot of you. I'm very aware that you're going to have other tests and assignments to get in, and an exam at this time of the year as well. So my warning is try and just stick to the 5 marks. The bonus 1 mark is something that will take you a lot of time to get to, but it's there if you want it. So the assignment dates are set out here. Believe me, they're a lot more softer than the degree. The degree's first hand in for exactly the same project is midway through, the end of this month for the first one. So it's the 20-something, and early to mid-October for the second one. And they are in the process of writing a 1,500-word design report at the moment. So maybe it was a good idea to tick the box that said diploma when you were doing your studies here. Okay. Yeah, so they're the dates, that's what we're heading towards, and there's a few tips there as well. If you want to get started, the best thing to start with is to start setting up your title blocks. There's one that I've put into that set there as well, so you could start your title block, you could start drawing up this. But more importantly, you should start on the reinforcing schedule, which today's lab is really important to attend, because and also Thursday's lab, because I'll be going over that side of things. Now, with the engineers, the surveyors disappeared. We can do what I used to do when I was in the workforce, and there will be a little bit of space in some of the classes to possibly come and attend both, okay? I want to put a proviso on that. There isn't enough room for all of you to fit into one class. I wish there was. We could all do it tonight and we wouldn't have to come back Thursday, right? But, so those that have paid for a seat tonight, that's your seat, all right? Same with those on Thursday. If you turn up tonight in the wrong class and there's plenty of room, that's fine. But if somebody's there that can't get a seat that's paid for it, I will have to ask students to leave, okay? Just fair. So there is a chance to turn up to both of the classes if you really want to put the extra 9 yards in. We've got a good student up the front here who's been giving me videos. I really feel like I should be giving you half a mark for doing that, but that would be showing bias towards one student, all right? So we won't be doing that. But he's been giving me some good videos of everything, so I'll keep uploading those, so you won't miss anything if you only attend one lab. Right, so this week's notes are here as well. Hopefully I can open them. For those that came in late, I am having a little bit of trouble today with this stupid monitor, but we'll get there. So I'll make the notes available now. So there is some overlap with other subjects. Now, a lot of you, not everybody, are what we call vanilla students here at Unitec, which is just going through doing exactly the chosen subjects each semester. Some of you fail things, some of you do 5, some of you are here for 50,000 years. And you're all doing different things, right? You think I'm a dinosaur. You're all doing different things here at Unitec. So you'll find it with my notes, like all the others, there's a little bit of overlap going on, particularly with materials, because you do concrete, steel and timber. But if you have a look at the materials notes, you'll notice that Ingrid's notes are very intense. There's a lot to them. If you want a good tip, don't miss her revision classes, because she tends to condense it down to a lot more of what you should be studying compared with all the notes. I'm not saying it's the answer to everything, but that's a good tip. Previous to her teaching at Roger Glanville, used to do the same thing. As far as my notes go, I tend to concentrate more on the things that are a little bit of an explanation of what something is and kind of what I'd like to see on the drawings, okay? So, for example, Ingrid might go into how concrete is manufactured, or how steel is manufactured, or the tannalization process of timber, and, you know, from going through the different stages, whereas I tend to say, well, okay, there's these types of timbers, and you've got to choose one and put it on the drawings, and this is how you should write it on your drawings, okay? So it's a little bit different. You may not see that subtle difference, but I do like to try and give you theory that I can test you on as well. So with concrete, the MPa value is a pretty important factor in terms of the strength of the concrete after 28 days. What's not written in my notes is that that's one of the questions. And what else is not written in my notes is that 20 MPa concrete is okay for the likes of an ordinary foundation slab for a house or something like that. But for this building, as you saw, and as my friend Mr. Mitchell there picked up, there is a tractor in this building, and that's fairly heavy. So it would be a good idea to put a reasonably good grade of concrete in there. So let's call it 25 MPa concrete, and let's make that one of our notes. It's not uncommon to say that the concrete should be 25 MPa after 28 days as a standard structural note on a drawing. By the way, when I say something and it doesn't appear on your drawing, and you start crying because you didn't get half a mark for your notes section, there's two types of concrete. There's plain concrete, which we are not using, but that can be found all over the place. It can be found on garden edgings, channeling, driveways, footpaths, curbs of roads. Basically unreinforced, so it's not going to last forever, but there's good reasons for that. Roads change in width from time to time, footpaths change, councils go down whole roads and redo the gutters, or they go through patching stuff. Dad decides to do a concrete drive, 10 years later he's sick of it and wants to do paving stones or put grass there. You know, it's not a long-term use, but it could be 10 to 15 years before you start needing to think about replacing it. Reinforced concrete, on the other hand, you would expect that to last quite a number of years. And we put reinforcing into concrete for New Zealand, in New Zealand terms, to strengthen it and to protect it against movement, particularly earthquake movements. And that's why an engineering certificate diploma degree in New Zealand is quite special because most of the other countries that suffer pretty severe earthquakes, I say most, are in third world areas where they don't actually reinforce concrete. They don't, where they should, but they don't have these very strict rules that we have in our country for building regulations. So, for example, if you went to work in somewhere like the outback in Australia where they have no earthquakes virtually, you know, to get a New Zealand engineer there that has done a New Zealand qualification is a little bit over the top in some ways. Same with third world countries too. Unfortunately, when it comes to third world countries, reinforcing, like a single reinforcing bar you might pay a week's wages for it. So what's going to happen is the contractors, or even worse, the staff, if they can steal one bar, they've stolen the equivalent of 800 New Zealand dollars. All right, if they could steal 5 of them, they've just stolen $3,000. So a contractor, by spacing the bars out and then going, you know what, no one's going to notice, on the back of the truck, has just made himself $800. All right. In New Zealand, a bar might be worth, I'm not sure, but I'm guessing maybe $10, maybe $5, and you lose your job trying to steal $5 off site. It's not on, right? So what you find in the third world countries, and it's quite sad, is what happens is the contractor turns up, he puts all the reinforcing down, they dig the hole ready for the concrete, the guy comes and inspects it, ticks the box, he drives off that way, the concrete truck's coming around the corner, they load all the reinforcing in, and they pour the concrete in, who's going to know anyway, okay? And they move it all to the next job. And it's not uncommon for that to happen, it happens all the time. And of course, they say, there's a saying in New Zealand that it's all very well until someone stabs you with a blunt stick in the eye. Well, what happens when an earthquake happens? Well, thousands of people die because nothing's reinforced. It's just concrete or clay, and you start moving it around, it just turns to gravel, right? So one of your first jobs as engineers, you might think that you've just got a job for, I don't know, maybe Becker's or someone in an office. Look at me, all I'm going to be doing is keeping nice and warm as opposed to this damn room. And I'm going to be watering pot plants, and I'm going to be on a computer all day. The ideal job, and then the boss will come up to you and say, what have you got on your plate this afternoon? And you go, well, nothing really. Have you got another job for me? Yep, I want you to go to such and such a site and count the reinforcing bars. And that's what happened to me. First day on my job. And I'm like, isn't anyone else capable of counting and reinforcing bars, right? It's not just counting it, it's measuring the distances between and how many there are. Now, you're going to find that most guys that do the steelwork on site are about twice as big as me that way, and they don't really like getting told what to do, all right? I guarantee most of them bend the bars like that rather than use a machine, but I was a young lad, about 18 or 19, and I had to tell this great big dude that he hadn't put enough reinforcing bars in. But his problem was he needed me to sign the piece of paper to take back to my boss, who signed the drawings off. And you know, I stood there and did it, and I was shaking a bit, but we got that out of the road. Why? Because a certified structural engineer has designed that to those spacings, to that size bar, to that many along there, and that will hold the building up, or the structure up, right? If you go on site and you go, oh yeah, that looks right, that's fine, you're responsible. The CCTV building in Christchurch, the guy on site had faked his engineering degree, true story, and the guy signing it off was too lazy to go and do it himself, and he got that guy to do all the site work. So I'm not quite sure who you blame for that, but in the end, it was not properly checked and it was not properly signed off. And look what happened. I mean, on the serious side of things, I think someone told me the other day, 2/3 of the deaths in Christchurch were in that building. So technically speaking, most of the rest of the city stood up pretty well, apart from some facades, some brick facades on the fronts of buildings. So yeah, that's a very important job, and it's something that you'll do, even if you're not a site engineer. Okay, if you're a site engineer, you're doing it every day. And if that guy, that big guy doing the reinforcing gives you trouble, you just basically tell him to leave site if he's not going to do his job properly. But if you're coming from an office like me, where you look like, they used to call us the suits because we used to wear ties in those days, and we looked like suits arriving on the job. It's just a very important part of the job, counting the reinforcing. The reinforcing rods, if you haven't done reinforcing yet with Ingrid, she will bring some into the class. I've got some in my office as well, and give you an example. These ribs here, they help bind the concrete, they help make it stick, they stop in any movement, they help bind the concrete to the steel and do the job that they're supposed to do. There's two types of reinforcing as well. There's the reinforcing where they put the tension on the bars, they pour the concrete around it, they'll snip the end of it, and that's pre-stressed concrete, and you'll see that on things like beams and also maybe walls and floors of car parks and things like that. And then there's what we call in situ concrete, which is where concrete is poured on site. I think it's Latin, in situ, I'm not 100% sure on that. But that's the next note that I would say I'd put on my drawing, is that on this job, is that the concrete will be in situ concrete. There's a little diagram there showing that we put reinforcing in concrete or brick to stop the tension, to protect it against shear stress, and to stop any cracks caused by tensile stress, which is concrete under tension. There's an example of caging, which I was talking about a few minutes ago. Very common to see that sort of thing on site. Usually we use plastic spacers now, so we get those spacers exactly right all the way along. If you are on site checking it, you would need to do that with either a ruler or some sort of mark to what you're expecting the spacings to be. It's all very well saying there's 30 bars, but if they haven't been nicely spaced, then there'll be big gaps, which is no good as far as the structure holding out goes. This is a photo that was taken about 4 or 5 years ago. It was in the Herald, of the guys starting the big piles over here at Waterview. You know how you come out of the tunnel and you go way up in the air, big piles holding that up. It was pretty cool. They allowed Unitec students to go on site and have a look at everything close up. So they would do what's basically this circular shape with the ties holding the main reinforcing up. They would have a situation where we had a lat, the reinforcing would stick out of the concrete like that, and then they would put the next piece of reinforcing in and tie it to that, and then they would move that big circular piece of formwork up to do the next pour, and then they would pour that concrete, and so on. They do another lap at the bar. So a bar lap became very important in that job because that would help hold each piece of reinforcing in place. And we have a calculation for bar lap, which is also in these notes, and you should include it in your notes somewhere. Generally speaking, the lap is 32 times the diameter of the bar, unless a table has been provided. Unless a table has been provided. Unless a table has been provided. On your job, on this assignment, 12mm bars have got a lap of 390, 16 have got a lap of 520. And a lap is when it's not the type of lap that you're thinking. It's a lap is when you overlap a bar. Okay? So what we do here is with a window, we have trimmer bars which go around a concrete window, right? And this is classed as the lap. With a door, it's exactly the same, but we don't have the bottom bit, okay? With reinforcing, if we don't have a long enough reinforcing bar, we have to lap it like that, all right, to continue it on. Your assignment's got a lap on it, and the lap is, there's a minimum lap required, and in this case, with the 16mm bars, it's 520 mils. With the 12mm bars, it's 390 mils. So that's how we could actually do that slab continuous all the way down the road, as long as we kept lapping the bars. In the old days, it was quite a hard job because you had to put wire around them, but now they have those plastic ties, you know, that you can buy anywhere. Just quickly do the plastic ties.
So one should be on the bottom, the next one should be on the top.
There's no specific rule as long as they're actually lapped. But there is a rule to make sure you don't go outside of the cover. I'll talk about that in a minute. So some examples of mass concrete is where most of the job is concrete. Would be a concrete gravity dam, like I worked in Central Otago on the Clyde Dam, which at the time was the second biggest, I think it still is, in New Zealand. Definitely the biggest concrete gravity dam anyway. Benmore is a earth gravity dam. Those black things you see there are what we call galleys, and you can walk through there and do various surveys to work out if the dam's moving at all. And it pretty much relies on the mass of the concrete holding the water back, which is a bit scary really if you live downstream from that. And it's also scary in that they were halfway through the build of that dam when they found out it was on a fault line, which was interesting as well. The Germans were building it. I worked for a German company, and they panicked a little bit, to say the least. So they started drilling into the rock, and the rock in that part of the world was called schist, which is German for something else, which is what they called the rock because it kept crumbling away. Which was interesting hearing their German. They always had the word schist in it. I was wondering whether they were swearing or talking about the rock. So concrete gravity dam, and here's another use for plain concrete by the likes of reinforcing for gardens and that sort of thing. In situ, there we are. Concrete, which is in its plastic form, is placed into position in the structure, is termed in situ concrete. So that's a long explanation. Precast concrete comes in many ways. This is the ones where you stretch the reinforcing and then you pour it around it in a frame, and then you take it to site. I know that when they do the motorway bridges, they bring everything to site at night time, and they stretch these precast slabs across the motorway. It would be impossible almost to build them in situ. you know, it would just be with all the traffic going underneath and all the rest. But this they can put 4 or 5 beams across in one evening. So 1 minute there's nothing, next minute there's a bridge across the motorway. So very good for fast construction jobs. Good for fast erection of car parks. You know, I don't know what experience you've had of driving around the city. 1 minute there's a vacant lot, next minute, boop, 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 there's a 4-storey car park up. And they tend to do that with tilt slabs, and they do that with, all of that is pre-stressed concrete. The old double T, I worked on Mount Albert Pack and Save, which is just down the road here for those that aren't familiar with this area. We were excavating and came across lava flow from Mount Albert from a few years back, of course. And once you hit lava, you've got to dynamite it, so you can no longer use the digger, and so that's a lot of extra money. And we had a very clever engineer in our office, and he said, well, what's the minimum height for car parks? And we told him. We went to council, they said no, whatever the twin T's or the uni T's are sticking down is the height we measure to. I suppose technically a car or a person's head could bang it. So my boss went away and designed some special twin T's that meant the height of that beam was a lot smaller. We didn't have to dynamite. They saved not millions, but a lot of money on the excavation works in terms of what we had to take out of the rock. Interesting job, that one. You guys that are doing structures, 1 or 2 of you, they talk about the deflection of a beam. The Pack and Save there is obviously all the stock in there is very, very heavy. So the beams had to be designed to take that. So they had to over-design the deflection so that when the weight went on it, the beams ended up flat, as we know it now when you walk into the shop. It was very interesting watching the forklift guys driving around as they were loading everything into the store when it was empty, because they were going like this. And, you know, sometimes the forklift would go like that and they'd lose the load that they had on. It was quite a tricky job. It was like a big trampoline. Even me walking around on it would, you know, I know you probably think that I'm the same weight as a forklift, but it was still bouncing a bit. So you'll find that uni T's and twin T's are used a lot where there's car parking situations underneath and they're looking for more space. That's just a little diagram on how we use slip form concrete to, we pour it and raise it in, as far as car parks go. Steel grades. Well, here's one of my questions in the test. The most common grade is 300. And the place that we get most of the new, or all of the New Zealand reinforcing it from is a place called Pacific Steel. I think part of that is now taken over by Fletcher's, but it's down in wk8, South Auckland. And because there's only the one place, it's all the steel comes out to New Zealand standards. They're always improving things, but generally in New Zealand we don't use welding as a way of joining the bars. You are asking what a lap is. The old-fashioned way is they used to just weld the end of the bars. That's generally not acceptable in New Zealand. They tend to overlap them. Big one?
Call it bracing, right?
Tight with steel wire.
They tend to tie that with steel wire or nowadays plastic.
So where the reinforcements flat, are they not actually connected to each other?
They are. They're tied to each other. They're not tack welded or anything like that. Generally speaking, no. The other thing is that if this reinforcing had an end to it, and so it had a bend in it, if you think about it, if that was one whole piece of reinforcing to put into a hole, it's rather awkward. You're coming in on an angle, it's not quite fitting at one end, it's very awkward to fit it into different shapes. If you break it down with a lap in it, you can put one bar in and then put the other bar in and then bring them to place. It's a lot easier for the guys on site to do it. And often what they do is they look at your drawing and go, nah, that's not going to work, it's going to take us like 2 days to do it. And they go, no, we'll put a lap in. So they ring up, the engineer will say, no, that's fine, put a lap in it, and then they can quickly put it all together. Yeah. Remember the bars go in the other direction as well, so there's quite a bit to the reinforcing side of it. There's some information there on the friction of reinforcing and the difference between plain bars and deformed bars. And there's a couple of pictures there as well. There's a picture of a driveway for those that have never actually helped their fathers do a driveway in the past. I guess it's changing times. I don't know if that many fathers do that sort of work anymore now, but back in my time, my dad and I did a driveway, and we didn't even put reinforcing mesh in there because it cost too much. And we didn't even put polythene down either. We just whacked the concrete in there and that was it, and that was fine for Dad. About 10 years later we had to replace it all again. When you put the mesh in, it does tend to last more like 15 to 20 years. And it's pretty standard for guys that come to site now to do that in that way. It was also a common thing for rugby clubs, soccer clubs, tennis clubs, whatever, to go and do somebody's driveway for them for a small amount towards donated to the club. But I guess a lot of that has changed as well. There's different building codes these days, and there's only so many people are allowed to do certain jobs on houses and things. There was a time you could do your own electricity and plumbing and all that sort of thing. But most things now have to be signed off by someone, a registered person. If you guys end up doing drafting, in structural drafting, after so many years you can get certified as a structural draftsman, which means that you could technically do your own house plans. I know architectural draftsmen, that's their big thing, to get certified so they can go out on their own and do people's basic house plans. And also with companies, it makes you a little bit more employable because you're already certified, so they can leave you to do the structural drawings on your own. Formwork and placing of formwork. Every year I do this diagram, and every year I put the question in the test on this. One or two of you already know this, so I'm just bear with me, but quite a few of the class won't know this. When we're pouring, for example, for a retaining wall, concrete around here, the concrete that we draw like that. We have our ground, this. And we have some bracing, kind of like the bracing you said, holding that up. So what we tend to call this is formwork. And this is tend to call false work. All of that, excluding the concrete, is called boxing. I'll put in here, not concrete. So what you'll have to do as site engineers and sometimes as office engineers is you'll get asked to give a dollar number for how much the boxing is going to cost. And a lot of it depends on what formwork you use. Sometimes they use metal formwork, which means they pour the concrete, okay, and then they move it along, they wash it down, and then they pour the next concrete. Move it along, wash it down, so you can reuse it. Obviously that costs more money, and it would be specific to that job. So you're not going to be able to reuse it again on another job. What tends more to happen is they use cheap timber shutters as the formwork. This stuff here tends to be throwaway. Put a peg in the ground, brace it, just chuck it away afterwards. Sometimes you can reuse it further down the job. But they will have a set rate for formwork and for false work, and that often needs to be included in your job. So one of the big questions that I ask is, what is the difference between formwork and false work?
So timber formwork is cheaper than steel?
Yeah, well, you think of the likes of, say you're importing something from, say, India, and you get it shipped over here, and it's got like a pallet around it to protect it, which is very thin, cheap timber, and you can pick that up for next to nothing, and it makes good formwork for something like a retaining wall. But if that was in your garden, it would be very rough.
How many times
Right.
can we use timber formwork for?
How many times
How
can
many
you reuse
times?
it? Not very much, because it gets when you pull it off, sometimes it sticks, sometimes you get concrete all over it and you can't wash it down, and so it's going to leave that pattern on the next bit.
But a steel one can be used. so
A
many
steel one,
times.
they just wash it down and just
Yeah.
move it along.
It's weird, how come is that cheaper than?
Well, the steel is more expensive, but you can keep reusing it, but you can only use it on that job, unless you've got lots of walls that size. Right. Yeah. Spaces, I mentioned spaces before, and there's a question on them and bar chairs. Bar chairs are strange things. They tend to they sit like this, and they put the reinforcing bars, they hold the reinforcing bars up, basically. So you have a series of those chairs all the way along the job at the right height. These are adjusted. They're made of plastic. They're left in the concrete. The main idea is to keep the bars from bending in the longitudinal direction and keeping them at the right height. Pouring concrete is another thing to consider, and another good note for this job. The job is, we're coming in from gate 4, we're going to have to go across grass. If you were doing it at this time of the year, you're probably going to dig the grass up completely, so it's not really a good thing to pour the concrete, to take the concrete truck. They're very heavy, you've got 6 metres of concrete in them. So it's not really a good idea to take that truck all the way to the site that we've got. So I would suggest probably something like the, wouldn't be directly from the truck. You'd probably use a hoist and a chute, and you'd either manually take it by barrow, or you would use some form of conveyor belt or pumping. My best guess is pumping. They have very long pipes that they can pump the concrete to the site. The guys just holding the pipe there, just spraying it all over the concrete slab, and they have at the other end they've got a machine that's pumping it from the truck, and he'll put his hand up, so that's enough, and they'll drop it off. One thing that's really important when it comes to concrete is, as an engineer, is to get very close to the right amount. That's why I'm making you do quantities. If you don't have enough, well, obviously you've got a problem. You've got a big problem. Somehow, within sort of about half an hour, you've got to get some more concrete there. And you've got a little bit missing to fill up. So that's a big no-no. Huge no-no, because it's setting. And once it's starting to set, when it's starting to set, once it's set, you're left with a big problem. So you tend to over-order. But if you over order too much, you end up with concrete back in the truck, all right? They charge you to get rid of that. So you're not only just getting charged for the concrete, you're getting charged for them to take it and put it somewhere. Now, their bosses don't care where they put it, so they've probably got someone down the road that's going to go, hey mate, I need some concrete, can you give it to me for such and such a price? So they're going to charge you to dump it, and then they're going to give it to their mate for some money in the back pocket. Okay, so it's a win-win for the concrete guy in the truck. So the concrete guy in the truck is saying, very quickly, he's going to say, oh look, you know, that's going to cost you this much, and then he's going to sell it as well and make some money on the way home. So from an engineering point of view, either have somewhere up your sleeve you can put it on site, I don't know, a path or something extra, or don't order too much. That's why I've always, when you see concrete being poured on driveways and that, there's always a neighbour with his barrow running over saying, have you got any extra concrete? Because there always is, and he can pick up some for free, right? Good tip too, if you're the neighbour. That always happens, because he knows he's saving the guy money, and you see the guy in the truck go, another neighbour pinching my profits. Compaction, Ingrid would have already taught you about the compaction and how they compact the concrete so there's no voids in it, and how they leave a nice smooth finish on it. Particularly polished floors finish for commercial buildings, etc. Very expensive polished floors in Auckland. It's cheaper up north for some reason, I'm not sure why. Okay, I was talking about cover. Your job has got a minimum cover on it, and in the lab today we'll talk about the minimum cover. The cover is the distance from the edge to the start of the reinforcing bar, not the middle. So you're going to have to take off half a bar diameter. Cover is, yeah, we're back to my favourite person in the office, the geotechnical engineer, in some ways. The cover is determined by the material that's in the ground. So if it's geothermal, it's going to have more effect on that steel, so you'll need more cover. If it's near salt water, you're going to need more cover. And just ordinary wet, damp Auckland ground, which you get at this time of the year, you will need a bit more cover too. If it's just air, it's usually okay for the standard cover, but if it's air near salt water, it's still going to have an element of salt in it. So that cover's predetermined by the engineer. Usually they look up tables, or they'll talk to the geotechnical engineer to find out what the ground material's like. If it's got salts in it, it also can affect it. So when you're designing reinforcing, that cover becomes very important, because if you put any bars too close, it's going to rust. If it rusts, the building's going to fall over. Okay? There's some explanations of stirrups and hooks. They tend to be bars that are smaller, that hold the main bars in. Before there was a picture of that column where all the guys were holding, were working on it. The stirrups were the bars going around like that. Lap and splice, we've covered that. There's the 32 diameter I talked about before, and there's your lap distance on the bars. They are pushed against each other, and I'd like you to draw them like that when the time comes. Cranking, I know there's a picture here, and I've only really put this here for information. Generally speaking, we don't do that anymore in New Zealand. It is an option. If you get into a tight situation, you can do it, but generally speaking, we lap it sideways like above. This is the one we tend to use.
Oh, can you explain one more time how how do we figure out that distance for that?
The distance from that point to that point
Yeah.
is equal to 32 times the diameter. Okay?
Yeah.
We generally use deformed bars in New Zealand. However, if there is a table, which your assignment has got a table, I showed you it, use that number. Sometimes they're the same, but always the table dominates. Okay. This is a little table of how you might calculate the costs for pouring concrete. I have done this before in the past. Your assignment doesn't have this, so you're fine. The 4 degrees have got to calculate the costings for the job, so they're going to have to take a lot of this into account. And we're going to finish today's lecture on this drawing here. So in this particular case, this is a plan view. So it's a bit like what you're doing up here. It's a plan view of the slab. And let me make this very clear, when assignment 3, you don't have to draw any of that structure. It's just the slab with the reinforcing in it. This here is a plan view of a very, very simple slab. It's not like that one, it's just a rectangle with a depth. And it's got 2 lots of reinforcing, one going in that direction and one going in that direction. And this is how we draw it. So this is your little introduction before we go to our labs this evening. So we draw that bar there. The exact width of the bar is 16 millimetres. How do I know that? D16. What do you think the D stands for?
Diameter.
The form. Don't make that mistake. Not diameter. 01. Any idea what the 01 stands for? We'll leave that. It was sort of, because the next one's 02. If you have a look at the bar running vertically, that bar is called 1202. There's no D in front of it, so it's not deformed, so it's a plain bar. It's 1202. The 12 is the diameter of the bar. The 02 is, well, it's sort of the mark. Let me explain the mark. It's not like Andreas Banderas or whatever his name is, in that movie where he was the mark. A mark is what we call each bar. So in this case we have a 16 millimetre diameter bar, this one, and we call that 01. So that's our first mark, our first bar. The next one is 1202. That's the next bar mark. The next one, if we had another one, might be, I don't know, 1603. That would be the next bar mark. So it sort of is the mark, but it's sequential. Your assignment's got 5 bar marks. I'll show you that in a second. And I'll show you an example of what you should be doing for your assignment.
Excuse me.
Yep.
So one is laying like this, another one laying like that.
Yep, we'll get there. Just hold on.
What are the arrows for?
Yeah, just hold on. Very exciting, isn't it? Not for me, but for you guys. 250. Any idea what the 250 stands for?
Height of
Someone said it over here. Is it space?
height of beam.
Space? What? No, it's the amount of dollars you need to give me to get a good mark. No, it's not. It's 250 is the spaces between the bars. So you were saying this bar is drawn along here. Well, the next one will be 250 away, and then 250, then 250, then 250, right?
And that one is going to be 300.
The arrows, another good question. This bar here's got a little circle on it, so by my reckoning, that must be tied up with that arrow, right? And the arrow points down to that. Now that is called a delimitator. not a terminator, delimitator. Like a terminator, because that's where it terminates. But delimitator here, and there's one up the top. So that tells me that that bar is 16 millimetre diameter. It starts here, which looks very close to the cover, ends up the top. There is 8 of them, right? And they're 250 spacings. Now the next thing you're going to say to me, but hold on, what if it does, what do I go 250, 250 and then a little bit at the end, or? No, you've got a space, when you are calculating it and drawing it, you work out the exact spacing, so it might be 246.3 or something like that, okay?
So we must get.
We used to in the old days draw the whole lot, but this is the new way of doing it, like this. Saves a lot of time. Now this bar, this way, goes from that point to that point. Delimitator to delimitator. If you want to know what size to draw this in the assignment, it's roughly 2 times the diameter of the bar. You can see this bar's a lot thinner because it's a 12 millimetre bar, and it goes from there to there. There's 20 of them, and the reason why there's 20 is that there are 300 spaces, and there's 20 of them from there to there. Probably doesn't look proportionally right, but that's what there is. And that is pretty much it in a nutshell, except this terminology here, which is the tricky part for this and for your assignment. We can have each face, near face, far face, top, bottom, top and bottom, each way, both ways, and all ways. And they're all abbreviations for the bars.
And will be given load on a slab?
Will you what?
Will be given maximum load on a slab?
No, you'll be given, if you have a look at your sketch, and let's do sketch 1. Let's go backwards. Let's zoom in here. You can see here on this sketch that at this end there are 6 bars, 1, 2, 3, 4, 5, 6. They are D12 bars, and they're evenly spaced. The ones running in that direction, the ones on the bottom, are D12s at 300 centres, and the ones on the top are it looks like, I can't quite see it because it's slightly out of view, D12s at 200 centres.
When it says they're deformed, does that mean they're like actually physically deformed in shape?
Sort of. I covered that before in the notes. It's all right. It's fine. They're not handicapped anyway. So these top bars are D16s at 200 centres, and these bars here are D16s at 300 centres. Now, when I said a game of Tetris, there are rules for these. Those lines coming down there cannot go through any of this text. They are allowed to go through any of those dashes. And same with that line there. Now the equivalent of what you've got to draw in that slab, you have bars on top and bars below, and you've got overlapping bars. You've got 8 lots of text to put on there in one direction, and I think 6 lots of text in the other direction. And you're not allowed any of those lines to clash with your text. So it becomes a game of Tetris to try to jiggle it around to get it in. Okay? So that's why I'm saying don't start this on Sunday beforehand. And just a little warning. So in today's lab, we're going to go over an example, and we may look a little bit closer at this. But I've also, in the other sketch here, where is it? No, that's sketch 1.
Just close that one.
I just closed it, okay. Yeah. It goes in the other direction, and it shows you what it looks like in the other direction. in the other direction, I did too. The slab goes like that, it doesn't have any footings on it, because we're looking at it through the centre here. So it's a little bit different as well. So you can leave here like half stun mullets, and after your lecture I will stun you a little bit more, because we're going to work our way through a retaining wall example. Right. Look at that, finished 10 minutes early.
Can you please explain in 10 minutes how can we take, I'm going to talk about last time, how could we take into account that compaction factor in our volume?
No, not the concrete.
No, but I'm talking about last assignment in past. Assignment 2, how could we take into account that compaction factor in our volume?
I can't tell you that because there are people that are handing it late.
This is past.
No, they take a 20% discount on their mark and they hand it late, so they get 3 marks off. And they wait around until they give the answer and they go away and correct that.
Okay.
But I can tell you that you were supposed to do it in the in the notes part of your you're supposed to put it, the compaction factor was summarised in the notes part of your main proposed drawing.
Yeah, no.
And the correct way to do it is, I can't tell you whether it's -5% or +5%, but it's quite complicated.